Welcome to this class. In this session, we are still going to give more examples on determination of tangent lines to curves at specified points. So the problem is find the slope of the functions at the given point then find an equation for the line tangent to the graph at those specified points. So first part, f of x is given by x squared plus 1, and then at the point 2, 5. So let's discuss this. So the first thing is to know the definition of slope. Slope is limit as h approaches 0, f of a plus h minus f of a divided by h, provided this limit exists, which will be limit h approaches 0. Our f of this case is 2. So 2 plus h minus f of 2 divided by h. Now f of 2 plus h will be 2 plus h squared plus 1, which is 4 plus h squared plus 4h plus 1, which is h squared plus 4h plus 5. Two squared plus 1, which is 4 plus 1, which is 5. So this implies that m is limit as h approaches 0, h squared plus 4h plus 5 minus 5 over h, which will be limit as h approaches 0. 5 minus 5 is 0, so we'll have h squared plus 4h divided by h. Factorize h, so m will be limit h approaches 0, h into h plus 4 divided by h. This and this cancels out, which will be limit h approaches 0, h plus 4. Direct substitution will give us 0 plus 4. So m is 4. So that's the first thing. And then equation of the tangent is y minus f at a equals to m x minus a. Our a is 2 for this problem, so we have y minus f of 2 equals to m is 4, x minus 2. And from our calculation, f of 2 is 5. So we'll have y minus 5 equals to 4x minus 8. So y equals to 4x minus 8 plus 5. So y equals to 4x minus 3. So that's the equation of the tangent to that curve at the point 2, 5. B, g of x is given by x over x minus 2. The point is 3, 3. As usual, define the slope. So slope is limit as h approaches 0. Now, because this function is g, so it will be g of a plus h minus g of a divided by h. A is 3, so g limit as h approaches 0, g of 3 plus h minus g of 3 divided by h. Now, g of 3 plus h will give us 3 plus h over 3 plus h minus 2, which is 3 plus h over 3 minus 2 is 1, so 1 plus h. And g of 3 is given by 3 over 3 minus 1, which is equals to 3 over 2. This is 3 minus 2, this is 2 here, so 3 over 1. So just same as 3. So therefore, m will be limit as h approaches 0 of this value here is 3 plus h divided by 1 plus h minus 3 divided by h. Now, by definition, let's put the numerator under 1 LCM. So we'll have limit h approaches 0. So I have h. So denominator will be 1 plus h, that is the LCM. And then I'll have 3 plus h minus 3 into 1 plus h, which will give me m limit as h approaches 0. I'll have 1 plus h, 3 plus h minus 3 minus 3h divided by h. I'll just open these brackets here. And you see 3 minus 3 is 0. So this is the same as saying limit as h approaches 0 of now h minus 3h is minus 2h over 1 plus h divided by h. So you have m is limit as h approaches 0 of now minus 2h over 1 plus h, and then dividing by h is the same as writing limit as h approaches 0 of minus 2h over 1 plus h times the reciprocal. And h will cancel out. So that we'll have m is limit as h approaches 0 of negative 2 over 1 plus h. We have direct substitution minus 2 over 1 plus 0, which is just minus 2. So gradient is minus 2. So equation of the tangent is given by y minus, so for this case, g of a, m into x minus a. A in this question is 3, so we'll have y minus g of 3 equals to m is minus 2, x minus 3. G of 3, we got the answer to be 3, so it'll be y minus 3 equals to minus 2 into x minus 3. So y equals to minus 2x minus minus is plus 6, and then plus 3. So y equals to minus 2x plus 9. That would be the equation for the tangent for that given curve. C, we have h of t is given by t cubed. So m will be limit as h approaches 0 of h of t, h of a plus h minus h of a divided by h. And this for this one is at the point 2, 8. So a is 2. So it'll be limit as h approaches 0 of h of 2 plus h minus h of 2 divided by h. Now h of 2 plus h will be 2 plus h power 3, which is 2 cubed plus 3, 2 squared h plus 3, 2, and then h squared, and then plus h power 3, just using binomial. So it should be 8 plus 12h 6h squared plus h cubed, and then h of 2, you simply put 2 where there's t, and then 2 power 3 is 8. So we'll have 2 power 3, which is 8. So then m will be limit as h approaches 0 of now 8 plus 12h plus 6h squared plus h cubed minus 8, and then divided by h. So m will be limit as h approaches 0, 8 and minus 8 cancels. So we'll have 12h plus 6h squared plus h power 3 divided by h. Factorize out h. So limit as h approaches 0, h into 12 plus 6h plus h squared divided by h. And then we can cancel out the h. This and this cancels out. So we'll have limit as h approaches 0, 12 plus 6h plus h squared. Direct substitution will give us 12 plus 6 times 0 plus 0 squared. The answer will be 12. So m is 12. So the slope is 12. And we know y minus h of a equals to m into x minus a is the equation of the tangent. So a in this case is 2. So we'll have y minus h of 2 equals to m is 12, x minus 2, and h of 2, we have gotten the answer to be 8. So we have y minus 8 equals to 12 into x minus 2. So it's not x bar, so this is function of t, so this is t. This is t, this is t, this is t. Remember we had this function was t, not x. So we'll have y equals to 12t minus 24 plus 8. So that will give us y equals to 12t minus 16 as the solution. Second last, D, f of x is given by square root of x at 4, 2. Now solution, you start by m, limit as h approaches 0, f a plus h minus f of a divided by h. So limit h approaches 0. A for this case is 4. So f of 4 plus h minus f of 4 divided by h. Now f of 4 plus h means square root of 4 plus h. F of 4 means square root of 4. So therefore m will be limit h approaches 0, square root of 4 plus h minus square root of 4 divided by h. Now this one, to be simplified, we need to use rationalization of the numerator. So m, limit as h approaches 0, root 4 plus h minus root 4 over h. So multiply both by the conjugate of this is 4 plus h, and then plus root 4 divided by root 4 plus h plus root 4. This will give us m is limit as h approaches 0. Now these are difference of two squares, so the same as 4 plus h minus 4 divided by h into root 4 plus h, and square root of 4 is just 2. So this is the same as limit as h approaches 0, 4 plus h minus 4. You don't have to open this, h into square root of 4 plus h plus 2. So m will be limit as h approaches 0. Here with this and this cancels, so it will be h into square root of 4 plus h plus 2, which will be limit as h approaches 0. Now h and h cancels, 1 over root 4 plus h plus 2. So this step round, now direct substitution will work. So 1 over square root of 4 plus 0 plus 2, which is 1 over square root of 4 plus 2. Square root of 4 is 2, so 2 plus 2, which is 1 over 4. So m is 1 over 4. And the equation of the tangent y minus f of a into mx minus a. A for this case is 4. So y minus f of 4 equals to m, which is a quarter, x minus 4. F of 4 from our calculation is square root of 4, which is just the same as 2. So we have y minus 2 equals to 1 over 4 into x minus 4. So y equals to 1 over 4x. This by this is minus 1, and then plus 2. So y equals to 1 over 4x, and then plus 1. And lastly, y equals to 2 root x at 1, 2. So this is 5. So f of x is 2 root 2, root 2 root x. So m is limit as h approaches 0, f of a plus h minus f of a divided by h, which is limit as h approaches 0 of f, a for this case is 1, so 1 plus h minus f of 1 over h. Now f of 1 plus h will be 2 square root of 1 plus h, and f of 1 will be 2 root 1, which are the same as 2. So m will be limit as h approaches 0 of 2 root 1 plus h minus 2 over h. Here you use rationalization of the numerator. So m is limit as h approaches 0, 2 root 1 plus h minus 2 multiplied by the conjugate of this h into 2 root 2 1 plus h plus 2. Now these are difference of two squares, so we'll have 4 into 1 plus h minus 4. First we'll be doing 2 root 1 plus h squared minus 2 squared. So the square of this is what's giving me this, divided by h into 2 root 1 plus h plus 2. We don't have to open this. The limit as h approaches 0 is the value of m. Now this will be limit as h approaches 0, 4 plus 4h minus 4 over h into 2 root 1 plus h plus 2. So m will be limit as h approaches 0. 4 and minus 4 cancels out, so 4h over h into 2 root 1 plus h plus 2. And this time round, h and h cancels out. So it will be limit as h approaches 0 of 4 over 2 root 1 plus h plus 2. And you see 2 is common in the denominator, so we can find write this as m equals to limit as h approaches 0, 4 over 2 into root 1 plus h plus 1. And by doing that, 2 and 4 divides. So this is 2, this is 1. So it will be limit as h approaches 0 of 2 over root 1 plus h plus 1. This stage, direct substitution will work, so that we'll have m 2 over square root of 1 plus 0 plus 1, which is 2 over square root of 1 plus 1. 2 over square root of 1 is 1 plus 1. So 2 over 2, which is 1. So m is 1. The slope of the tangent is 1. So equation of the tangent y minus f of a equals to m into x minus a. So y minus, our a for this case is 1. We have gotten our m to be 1, x minus 1. So when we replace f of 1, our answer from the previous calculation is 2. This was the answer here. F of 1 is 2. So y minus 2 equals to 1 into x minus 1. So it is 1, y minus 2 equals to x minus 1, or y equals to x minus 1 plus 2, which tells us that y equals to x plus 1. So that is the solution. Thank you.